Okay, let's do another ANOVA test example. So this time we have a random sample of people asked whether they were athletic, moderately athletic, or not athletic. So again, we've got 3 different categories here, and that's why we end up into the ANOVA test situation. Once they defined which one of those categories they were in, they were tested for reaction speed. Shorter distances correspond to faster reaction times. We want to test the hypothesis that people with different levels of athletic ability have different mean reaction times. Okay, so this data is shared under Donahoe Athletic. If you want to pull that up, I'm going to do that here in just a minute. But first I'm going to get it set up. So first I want to write the null and the alternate hypotheses. So the null is the same for any of these, and that's that we're assuming that I'm going to label them not. The mean of the not athletic is the same as the mean of the moderately athletic is the same as the mean of the athletic. And again, that's the same thing as saying there is no association between what athleticism and reaction speed. And my alternate that is that at least one mean is different, and that there is an association, Okay, so then we have to check our conditions. It says, are the sample sizes large enough? And if not, what must we assume in order to proceed? So it looks like we only have 1, 2, 3, 4, 5, 6, 7 here. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12 here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. So none of the sample sizes, so all ins are less than 25. So that's no good. So if we're going to proceed with our problem, we have to at least note that we are going to assume normality to continue. So we would have to take these results with a grain of salt. We would need to maybe do a little bit more research. We don't know if the population where these values came from are normally distributed or not, but we would have to assume that in order to continue. Otherwise, we get stopped here. Okay, we're going to bring up StatCrunch and enter this data or pull it up, and then as we perform the test, we're going to check that homoscedastic condition. So I need to load data from shared, and I am going to search my name, and I should have done this ahead of time, but I didn't. So this is what you would be looking for. Let's see, we're looking for the one called athletic, so I think it's actually on the next page. Where is it? Let's see, it's here somewhere. Just didn't see it. There it is, athletic. Okay, so that pulls up all of that. Now I can go into my stat ANOVA to run the ANOVA test. So we've not actually run one yet. And again, all we ever run is a one-way. We need to select the columns. So I want to choose all of those columns. And notice here we can even test the homogeneity here, but I don't even really need to do that. All I need to do is compute. And so it's running the test. But what I want to do is I want to check, so I'm going to look at the standard deviations. So again, look at the standard deviations, not the standard errors when they're given. So it looks like my smallest is 5.3 and my largest is about 6.95. So when I flip back over to check this, I want to make sure that the largest, the 6.95, is less than or equal to twice the smallest, which was 5.3. And again, I can just tell by looking at that that's going to work, because this will be over 10 over here. So 6.5 is definitely less than that. So I'm going to check that off. So we are good. Now that we know we're good, we can record the F statistic and the p-value. So I can flip back over here and find those. They're down in this lower right-hand corner. So it looks like my F stat is about 0.104 and the p-value is 0.9015. So F is 0.104, P is 0.9015. So again, to remind ourselves what this kind of looks like then is it's this right skewed distribution. F is very small. F is down here at 0.104, which in turn makes this p-value very large. So then our conclusion will be, since P is greater than 0.05. Again, we weren't told what to use, so I default to that one. So it's bigger than that. We're going to fail to reject the null. So what that will mean is that the mean, so we're failing to reject this, so basically we're sticking with it. So it looks like the mean reaction times are all basically the same. For all three groups are the same. And hence what that means is that there is no association between your athletic ability and reaction time.